Hi, in this video we review the usage of the interfaces. What are the interfaces, and what is the goal of them? Let us take an example from the real life. Let's have a car that was produced in 1975, so this is an old car. And let's have a car that was produced in 2020. The similarity between the two cars is that we can find in both cars a steering wheel, a gas pedal, and a brake pedal. We have a driver who drives the car with the steering wheel, gas pedal, and brake pedal. In the car, let's consider the steering wheel, the gas pedal and the brake pedal as an interface. In both cars, the interface elements, that is the steering wheel, the gas pedal, and the brake pedal have the same purpose. With the steering wheel we must be able to change the direction, with the gas pedal we must be able to go faster, and with the brake pedal we must be able to slow down the car. The average driver does not take care about how this is accomplished technically behind the dashboard, that is behind the steering wheel, the gas pedal, and the brake pedal. For him or her the point is that if he or she uses this equipment, that is these interface elements, the car must react as it must do. So we have an iCar interface. We name this interface in this way in case of both cars. This interface has elements, the steering wheel, the gas pedal and the brake pedal, and how these functions are accomplished by the cars. We do not take care about this. We see an interface in front of us, and we use the elements of this interface. In the software development, the usage of the interfaces works in the similar way. If we have a software component, that is in our case the driver, and we have two different software components that implement this iCar interface, the driver software component will not take care about what the given software component does inside. The interface declaration will specify a goal how a software component should implement the interface elements, but how it is done is up to the software component. What is visible for the driver software component is a steering wheel, a gas pedal and a brake pedal. We are going to create a sample application that demonstrates the usage of the interfaces. In the following we are going to create a C# project. In the Microsoft Visual Studio I go to the File menu, New, Project. We are going to create a Windows desktop application and a Windows Forms application. In the next step we specify the name of the project and solution. I specify the name of the project, C# interface example. I specify the folder where the solution and the project should be created. The name of the solution is automatically the same. I didn't change the .NET framework, I kept the offered one. And finally I asked the Visual Studio to create a folder for this solution. With clicking the OK button we create the project. The project has been created successfully with an empty form that will be the main window of our sample application. As a first step I created a user interface design. The design was created with the Windows Forms Designer of Visual Studio. I used the elements of the toolbox. What is important for us at this point is that those elements that were added to the form should be added by the viewer of this video. If he or she tries to implement this project based on the video content, because the source code of this sample application will refer to them. It is not important how the user interface elements will be aligned. What is important for us is that the user interface elements must be created with the same name. So we have a button, with the name of button increase counter, a button, with the name of button log to file, a button, with the name of button log to screen, a label control, this is the activity log, a table layout panel control, this is not so important, we won't refer to this. The role of this control is only the providing of a layout for the controls. We have a text box control and the form itself. If we run this sample application, according to my design, the controls will follow the window. The activity log will expand or narrow down when the window is being resized. In the next step, we create a backend software component that will be controlled by this form. We select the C# interface example project. With the right click we open the context menu. We select the add menu point. We select the class menu point. Then, for the name, we specify the name of the new software component. The name of the software component will be backend software component. And finally, with clicking the Add button, we add this software component to the project. The Visual Studio automatically puts this software component to the default namespace of the project. In this case, the backend means that this software component will be running in the background. In other words, we are talking about a software component behind the user interface. As a next step, we create an instance of this backend software component. In the form that was created earlier, we select the Solution Explorer. With the right click, we select the form, and finally we select the menu point, View Code, in order to see the code behind the form component. First, we realign the code in this class. The usage of the regions can make the browsing of the source code easier, if someone does not like to use the class view. In this case, the segments of the class implementation can be collapsed or expanded, and we can make those parts visible that are important for us at a given moment. I usually create code segments that are similar to the Microsoft documentation, so I created a region for constructors and a region for the fields. We are going to place our new backend software component in this fields region. The Visual Studio marks the new line with a green underline, which means this new field is used nowhere in the source code. Let's create an instance of this backend software component in the constructor of the form. As a next step, let's create an internal counter in our backend software component. With the right click, with the context menu, let's go to the definition of the backend software component. Let's create an internal counter field in the backend software component. Let's create a method with which we can increase the internal counter's value by 1. Now we go back to our form. We open the designer. And we add an event handler to the increase counter button that will be called when the user clicks the button with the mouse. We select the button, increase counter, interface element. And we add an event handler to the click event. According to my naming convention, my event handlers begin with event handler. In the middle section I add the name of the software component that the event handler belongs to, and in the last section I specify the name of the event. With pressing the Enter key, let us create the event handler in our code. The new code of the event handler is added to the end of the class implementation. Now I make some realignment in the source code. I have put this method into a region of methods. With this step, our class, in the collapsed status, has 3 regions: the fields, the constructors, and the methods. Now we are going to implement the event handler's logic, that is, let us call our form's backend software component's newly created method, the increase counter. We make a debug version test now. I have placed a breakpoint to the beginning of the event handler. We run the code, then, with clicking the increase counter button, we arrive to this event handler. Our internal counter field has the default 0 value, as it was initialized by the .NET framework, and now we are going to increase this field's value by 1. If we click the button once again, the internal counter's value will be 2, and so on. Whenever we click the button in the user interface, the counter will be increased by 1. With these steps we achieved that we can generate an event from the user interface that triggers an activity in our backend software component. So, at this point we have a backend software component. This backend software component was placed in the form, so the owner of this component is the form. The form creates and manages it, and later, the form will have the responsibility for disposing it correctly. As a next step, in the backend software component, we create a method with which we can set an activity logger. This method has an argument that receives a reference to a software component that will log the activity of this backend software component in some way or other. In the current status of the implementation, this will be the form. We create a new field in this backend software component that will hold a reference to the actual activity logger software component. Now we implement our logic. In our set activity logger method, we save the actual activity logger reference in the newly created field. we return to the constructor of our form. Previously we created an instance of our backend software component here. Now we set the actual activity logger to our form component. Now we are going to debug a bit. During the debugging process we arrived to the instance creation of the backend software component. Let us step into the method. If we expand the content of this software component, we can see that the activity logger reference has not yet been set. With this call we set it to the default logger, namely the form control. In the main window of the sample application, that is in the form, we create a new public method. This method has no return value, that is void. Its name will be logActivity. As an argument it will get a string message to be logged. We extend our already existing method in the backend software component, namely the increase internal counter. As a first step we implement an inconsistency check. The system, diagnostics, debug. A certain method expects a Boolean value as its parameter. If this parameter is not true, in debug version our software will display an error message. This is important here, because if the activity logger is a null reference, we get an exception in the next statement. We call the logActivity method of the referenced activity logger software component. We use a formatted string. Backend software component internal counter is increased. The 0 character within the curly bracket will be replaced with the actual value of the internal counter field. Let's see this in a debugging process. Our program is running. We call our method with pressing the increase counter button. The internal counter's value will be increased by 1. Consistency check. We step into the method with the F11 key, and let's see what we get in the parameter. So we get, backend software component internal counter increased, the actual value is 1. Whenever we press the button of increase counter, the same method will be called, the internal counter's value increases by 1, and the backend software component informs the actually set event logger. Now we implement the logActivity method of the form, which is our current event logger software component. We get a log message. We check if our textbox user interface control already contains any text. If it does, so its text property is not an empty string, then we add a line break to the current value. The line break is a \r/\n text. And finally, we append the new log message to the current text of the textbox control. Let's see this in a debugging process. We increase the internal counter. We arrive to our method. At the moment our textbox control does not hold any text, so we do not need to add any line break, we simply add the log message. The first activity log message appears in the user interface control. Let us increase the internal counter's value one more time. The logActivity method becomes called again. This time the textbox user interface control will contain a text. We append a line break text. And finally we add a new log message arrived through the argument. As we can see, our textbox control will display every single log message in a new row. As a next step we create a new software component. In the Solution Explorer this can be found in the IActivityLogger to file.cs source file. In the class view we can see that here, IActivityLogger to file. The open document contains the C# code file that was generated by the Visual Studio. Here we can see an empty class. Now we return to our form class, and we add a new field. We place our new IActivityLogger to file software component into the form. We open our form in design mode. We choose the button of log to file. We choose the events section of the properties tool window, and finally we create an event handler for the click event. With pressing the enter key, and after making some realignment in the source code, we get an empty event handler method in our form1.cs file. Let's make some debug tests. Let's click the button of logging to file. We can see that our newly created event handler gets called. We achieved the status, where we have two logger components. One of them is the form, that is derived from the .NET form. The other logger is the class of IActivityLogger to file. We can see as well, that the base class of these two classes is not the same. The class of ActivityLogger2File is not inherited from the form. Previously, by default, we set the ActiveLogger and the backend software component to the form. When we click the button of Log2File, we would like to do that we set the new ActivityLogger2File component in the backend software component. We make an attempt, but the Visual Studio tells us that it cannot accept this reference, because the parameter type is a form, but our new software component does not derive from the form. We would like to achieve that we do not implement two logger methods, one for the form, and one for the file log, but we have only one logger method, and independently of the logger object type, the method could log in a transparent way, either to the user interface, or to the file. Because there is no common parent, we cannot specify a common object type for the parameter. In this case there is a way for solving this problem, the usage of the interfaces. We implement an interface in front of the class of ActivityLogger2File. The interface declaration begins with the interface keyword. Right after that we specify the name of the interface. In this case we identify our interface with the name of IActivityLogger. At this point this interface does not hold any element. Now we improve the interface. We implement the method that was implemented by the form already. In the interface declaration we do not specify any visibility for the method, that is private, protected or public. In the selected rows we modify the implementation of the form. With the modification, our form will not only derive from the .NET form, but with a comma, I added the IActivityLogger interface. That means, our form, that is the main window of our sample application, will implement the IActivityLogger interface. Since we already implemented this log activity method, with a public visibility, we do not need to do any further step in this class for implementing the interface. Let us go to our backend software component where we added the ActivityLogger in a field. Now the type of this field is the form class. Let us modify the type to the IActivityLogger interface. Now we modify the parameter type of the setActivityLogger method. From now on the method will expect an ActivityLogger object reference with the type of IActivityLogger. If we compile and build our code, the Visual Studio will display an error for us, according to which the problem is that our ActivityLogger2File class does not implement the IActivityLogger interface. Therefore this object reference cannot be passed to the setActivityLogger method. Now we implement the interface on our new ActivityLogger software component. Since our ActivityLogger2File class inherits from nothing explicitly, only in a hidden way from the .NET object class, we implement the interface with using the colon character after the class name of ActivityLogger2File. If we build our sample application, we will see an error message, according to which our ActivityLogger2File class does not implement the method of log activity. Now we are going to implement the method. After compiling the source code we see that there is an error message. The problem is that if we want to implement an interface method, or any other interface element, that implementation's visibility must be public. So let us add the public keyword in front of void. Now our source code can be successfully compiled. Let us take a look again at the selected method. Now we are going to debug the application, and let's try to set in our backend software component this new, at the moment empty ActivityLogger software component. We click our button, Log2File, the program stops at the breakpoint. We would set this ActivityLogger object with the setActivityLogger method, but we can see in the autos window that this field's value is null. We create the ActivityLogger2File object when the user clicks the button, so we implement a code with which we create the logger component. The code segment within the if statement runs only if the logger object is not yet created. Let's run the application. With clicking the Log2File button, again, we are here in our method. We do not have an ActivityLogger2File object, therefore this object will be created. Then we set this logger object in our backend software component. Our actual ActivityLogger is the form. Now this will be set to the component that logs to a file. Let's increase the internal counter in the backend software component. The internal counter field's value will be increased by 1. We make a debug check if we have a valid, existing ActivityLogger object. Yes, in this case we have. Finally we call the log activity method. So now, the call goes to the file logger component instead of the form, but the log activity method is currently empty, not implemented. After some realignment in the code, we are going to create a new field in our ActivityLogger to file software component. We add a StreamWriter object that can be found in the system IO namespace. In the next step we check in our log activity method if this StreamWriter object already exists. Now we improve our method with a new statement. In the namespace of system environment, there is a getFolderPath method. We pass the enumerated value environment special folder, my documents, that returns the full path of the documents folder on the user's computer. The returned value is stored by the local variable of str, my documents path name. Its value can be seen in the autos window, in the row marked by the red color. The documents or my documents folder in the Windows system allows us the creation and writing of a file. Now we create a constant string field in our class. This will specify our log file's name and extension. We improve our log activity method. We append the log file's name to the documents folder's path. Then we use the file class createFile method to create a StreamWriter object. The createText method expects the path and name of the text file to be created. Now we run our application. After setting the logging procedure to a file, and increasing the internal counter by 1, we arrive to our log activity method. Since this log activity method runs for the first time, our StreamWriter object does not exist. We request the path of the My Documents folder. We make the string concatenation. The result can be seen in the Autos window. Then we create the file. In this case this is a successful operation. So we get a valid reference to a StreamWriter object that we store in our class field. Now we improve our method. We add new statements that writes the log message, passed by the argument, into a new row, in the text-based log file, and we call the flush method of the StreamWriter object, in order to write the cached data into the file physically. During debugging our application, we are at the position right after the creation of the text file. We can see our log file in the Documents folder. The file has successfully been created. If we open it, this file is currently empty. In the log message the actual value is 1, so we increased the internal counter for the first time. We write the log message, we flush the internal buffer, so this log message immediately goes to our file. The log message has successfully been written to our log file. If the increasing of the internal counter happens again, as we are going to do that, then our StreamWriter object will exist, so we do not want to open the file again. In this case for me, this is my third operation, so we immediately write our log message, we flush our internal buffer, and let us see the content of the text file. Really, this is our third increase of the internal counter, and all of the 3 log messages, as we can expect, have been written to the log file. Now we implement the click event handler of the log to screen button. We start debugging our application, and let us click the log to screen button. The event handler implementation was successful. The debugging process correctly arrives to our method. Earlier, in the forms constructor, we set our form as the current ActivityLogger object, for the backend software component. Similarly, we do the same in the event handler. Let's make a test if our concept has correctly been implemented. With the following use case we try to prove that both loggers work correctly. Let's run our application. We increase the internal counter by 1. By default the logging goes to the screen. Let us click the Log to File button, in order to log to file in the next round. The current ActivityLogger, which is the form, is going to be changed to the file log. Again, we increase the internal counter, we set back the logging feature to the screen, our actual ActivityLogger changes to the form. We increase the internal counter, again, we log to file. Then we increase the internal counter, Let's open the log file, and see its content. We can see that in the case of 1 and 3, when the logging was directed to the screen, the logging was performed in the user interface control, while in the second and fourth round, when we directed the logging to the file, accordingly, the logging was accomplished in the file. In the next step we start dealing with our form's dispose method. When we close the form, the .NET framework calls this dispose method. When the project is created with the Microsoft Visual Studio, the Visual Studio wizard places the form's dispose method into the designer file. Now we are going to move this dispose method to our simple CS file, that is altered by the programmer during the development process. After cutting the dispose method from the designer file, the designer source file looks like this. The simple CS file has been improved by the dispose method, with a bit altered version of this method. If the a, b, disposing parameters value is true, as the comment shows for us, we must dispose our managed components. If we have components, so this field's value is not null, we call it dispose method. Finally, at the end of the method, we call the base class implementation of this method. Let's see in practice, when is our method called? For this, we start debugging our sample application. Let's close our sample application's main window. The debugging process stops at the breakpoint that was placed to the beginning of the dispose method. In our ActivityLogger to file software component we implemented a StreamWriter object. This class has a dispose method implemented. Therefore in the class of ActivityLogger to file, we are going to implement a disposing feature. In order to implement the disposing feature, now we visit the documentation website of the Microsoft company, where we will see a template how we should implement the dispose method. In the first step we are going to implement the disposable interface for our ActivityLogger to file class. The ActivityLogger to file class already implements an interface. We add a new interface support with the comma character, right after the previous interface specification. As a second step, we implement a C# destructor method. What you can see in the screen now is the template I used from the Microsoft website. We rename the new destructor. This destructor will call our dispose method with false argument value. As a next step we implement the interface method that has no argument specified. Now we implement the dispose method that has a Boolean argument declared. We make some re-implementation in this method, so it will fit to our concept. We are missing a Boolean field in our class that signs to an instance of this class that its resources have already been freed. In other words, the object instance has already been disposed. Now we are going to add this field to our class. We build our code that now can be compiled successfully. In this software component there is one object instance that must be disposed of, our StreamWriter object. We call it dispose method, then we clear the reference. Now let's switch to our form class. The ActivityLogger to file software component is created only if the user has already chosen the logging to file feature, so we implement an if statement. If the ActivityLogger to file object exists, we call it dispose method, then we clear the reference. The backend software component does not hold any object that is owned by this class, and it would have a dispose method, so for this component, we do not need to implement a dispose method. In the form class we simply clear the reference of the backend software component. Now we implement a dispose Boolean field also in our form class that signs if the dispose method has already been called. Now we extend the form class dispose method. We implement an if statement with which we check if the object instance has already been disposed. If it has, we simply return. Before calling the base class implementation, we set the field's value to true. In the ActivityLogger to file class, the StreamWriter object is created only if the log activity method was called at least once, so in the dispose method we must check if the StreamWriter object instance exists. At this point let's check our implementation with debugging. Let's see what we have done so far. Let's set the login to file with clicking the user interface button. Control of log to file. We increase the internal counter's value by 1, then let's close our application. The debugging process stops at the beginning of the form's dispose method. The dispose method has not yet been called, so our field's value is false. The argument's value is true, so we must dispose the managed components. We have an existing ActivityLogger to file object, so we call the parameterless dispose method that we implemented previously. This method calls the other dispose method with true argument value. We check with the if statement if this object instance has already been disposed of. We need to dispose of our managed components. Since we logged a message to the text file, we have an existing streamWriter object, so we call the dispose method of this class, that is implemented by the .NET framework, and we clear our stored streamWriter reference. Finally, in this method, we set our disposed field to true, to sign for the object that this object instance has already been disposed of. We can check our class instance, the disposed field changed to true, the streamWriter reference has been cleared, and we do not deal with the constant string field. Going out from the stack, the dispose method of the ActivityLogger to file has been called, we delete the reference, and we do the same reference clear in case of the backend software component. We set the disposed field's value to true, and finally, we call the base class implementation. If we check the fields of our form instance, the ActivityLogger to file reference has been cleared correctly, the backend software component reference has been correctly deleted, and finally, the disposed field's value has been changed to true. After pressing the F5 key, we stop the debugging process, and according to my software development method, we can say that all objects have successfully and precisely been disposed of. In the dispose method of the ActivityLogger to file, again, let's request the full path of the documents or my documents folder. Let's add the name of our log file, then with the system.io file delete method, let's delete this file from the file system, so we do not preserve a junk file on the user's computer. With this step we achieved the end of our sample application. Thank you for watching it.